Hello. So today we're going to talk about relationships between categorical variables. So we've already talked a little bit about categorical variables in general and how we display them and graph them and talk about them. But today we're going to look specifically at how we describe the relationships we see between categorical variables, how they affect each other, etc. So to do that, we're going to talk about the Titanic. So the Titanic, there's a couple pictures for you, launched from Liverpool on May 31st, 1911. And if you didn't already know, spoiler warning, it sank in the middle of the ocean. And the number of passengers who died or who were lost was 817. The number of crew that were lost was 673. And we can kind of see 62% of passengers died, 76% of crew died. What we're going to look at is how their passenger versus crew status might have affected or might have been related to whether or not they died. Total, 68% of people who were on the Titanic lost their lives. So let's look at what we call a two-way table. We've talked about this before. It also might be called a contingency table. This allows us to look at two categorical variables together. So for this one, I'm looking at whether or not the person lived through this incident or whether they died. We also looked at, and instead of just looking at passengers as a total, we looked at people who were in first class, second class, and third class on the ship, and then the crew. So what we have here is just the total number of people who lived and died within each section. And yeah, so that's a two-way table. One little vocabulary extra. If you ever see something referred to as the marginal distributions, it's basically referring to the totals. So if I wanted the marginal distribution of like class status or passenger status, then I would be looking at the totals within each first, second, third, and crew. If I wanted the marginal distribution for whether or not they died, I would look at the totals for alive and dead. So like we talked about previously, if I were asked questions about percentages, remember I'm looking for the word of, so what percent of the people on the Titanic died? Well, that would be 1490 out of 2201, because 1490 total people died out of 2201 total passengers, which is about 67.7%. What percent of the people were surviving crew? Well, surviving and crew, there were 212 of them out of 2201 people total. If I ask you what percent of the survivors were first class, so of the survivors means I only care about the people who lived. In this particular instance, that sounded kind of cruel. And in that alive row, we have 203 first class out of 711 total. And then if I ask what percent of first class survived, right, it seems like it's the same question as the previous one, but now we're talking only specifically about first class. So only looking of first class, 203 survived out of 325 total. So looking at the word of is a good clue. It kind of helps us know what's going to be the denominator by looking at the word of. We also could do what we call a conditional distribution. A conditional distribution basically means that we are separating our two-way table based on a condition, and then within each of those categories, finding percentages. So in this case, if I separate it on the condition of survival, that means, okay, I'm just going to look at everyone who lived and everyone who died and find out what percent of each row were in first, second, third, and crew. So for the people who lived, I would say, okay, what percent were first class? 203 out of 711. For second class, 118 out of 711. So I found each of those percentages for people who lived, and then I did the same thing. So 122 out of 1490, 167 out of 1490, 528 out of 1490, etc., and found the percentages. Because we separated it on the condition of survival, within each row, those percentages should add up to 100 because we're doing it out of the 711. Same thing for the people who died. This percentages should add up to 100 because I did it out of 1490. So I'm kind of separating my table on that condition. As a side note, it would have been perfectly acceptable if I was more curious about what percent of each class survived or died. I could have separated it like vertically on the condition of class. So I could have looked at 203 out of the 325 who were in first class, who died, etc. So we could have done it the other way. For this one, I just chose to do it by survival. Right. And then from that, I could do a couple of things in terms of graphs to compare those percentages. So for example, I could make two pie charts where I looked at the people who lived and the people who died and what class they were in by a pie chart. And that works. Typically speaking, in statistics, we don't use a lot of pie charts just because there's better ways of visualizing data that's a little bit easier to make, but we could do that. Another option is I could just do a simple side-by-side bar graph with the numbers of people who in each class who lived and died. And that would be one way of kind of looking at that conditional distribution. One thing to note though is that third class and crew had a lot more people in them in total. So both of the bars are a lot taller simply because there's more people. So when we look just at numbers in these two-way tables or in these two variable comparisons, the numbers themselves are not always going to be the best thing to look at if we're trying to determine a relationship. So we're going to make something we call a segmented bar graph. This is something that you're commonly asked to make on an AP exam. You will probably see a question or two about it. We talked about it previously in the year, but a segmented bar graph is basically displaying the same information you would on two pie charts, but it's doing it with bars instead of circles, which makes it a little easier to compare side to side. So if you look down here, I have the information from when I did my conditional distribution as separated based on the condition of survival. And within each alive and died, I found the percentages that were first, second, third, and crew. So remember, we did 203 out of 711, 118 out of 711, etc. So once I have those percentages, right, I can go ahead and draw a simple graph. I'm going to have one bar that represents the people who lived and one bar that represents the people who died. And I'm going to be separating them into first, second, third, and crew. A segmented bar graph is basically where we stack it on top of each other. But I want to use proportions instead of numbers, which is why I found the percentages here. So I'm going to label my y-axis with proportions or percents. And I'm going to go all the way up to 100 on my y-axis because, again, I'm going to stack these bars on top of each other, and we know that they add up to 100%. So the way I would do this is by looking at my first class. So for people who lived, first class was 28.6%. So I'm just going to kind of estimate the height of that bar to be about 28.6, so a little under 30% represents the first class. The next one is second class, which is 16.6%. Now, because I'm stacking them, I have to do a little adding as I go. This tells me that I want my second bar. If I add 28.6 plus 16.6, I would get somewhere around 45% if I'm doing my math right. So that way I know where this second bar should end for second class. So it started at about 28.6 and it's ending at about 45. I think it's 45.2. So that would be that second class bar. Then I'm going to stack on top of that the third class bar. So again, we were at about 45 and we're adding 25. So that should end me at about 70. So again, I'm starting it here. So it needs to end about 70%. And then my last bar is crew, which is about 29.8%. So that last bar, when I add it on, should end at 100 because, again, the percentages add up to 100. So we're stacking them on top of each other so that we can see how that living section is split up. So then we have the people who died. So we're going to do the same thing. First class is 8.2%. Second class is 11.2%. So that will give me at about 19.4, a little less than 20. Third class is 35%. So that's giving me all the way up to about 55%. And then crew is 45.2%, which is going to get me up to 100. So that is our people who died segmented bar graph. So once we do that, we are able to very easily compare the people who died with the people who lived and see the differences in those percentages. So I can see very, very clearly that first class was much more likely to survive compared to other classes than die. I can see very clearly that crew and even third class were much more likely to die compared to the other classes and compared to the people who lived. So I'm very easily able to do that comparison because I have those right next to each other, and it gives me kind of that same order of classes, and I can see the colors and compare them. Can't talk. So then we're going to talk about how we describe that relationship we see in words. And the words that we use are either associated, they're associated variables, or they have an association with each other, or we might say the word dependent. So when we say class and survival are associated or they are dependent, we're saying basically that we notice a difference in the percentage of people in first, second, third, and crew for alive versus dead. So because I'm seeing a difference in percentages across the board for people in each class for alive versus dead, that kind of tells me that there seems to be an association, right? Whether or not you lived or died seemed to have some kind of effect on what class you were in, or the class you were in seemed to have some effect on whether you lived or died. Those percentages are different, so we're seeing that there's some kind of relationship here. Something's going on where these two variables are connected and are affecting each other. If the variables or if the percentages were the same, so for alive and dead, if the percentages of first, second, third, and crew were about the same, maybe not exactly the same, but if they were pretty close, like within a percent or so of each other, all across the board for all of the class categories, then we might say that they are independent or not associated, because that would tell us that clearly what class you're in doesn't seem to have much of an effect on whether you lived or died. Whether you lived or died doesn't seem to have any effect on what class you were in on the ship. So just to kind of reiterate that, independent is the same thing as there's no association, basically means that there's no relationship between the variables, and that would mean that the percentages are roughly the same for all of the categories between the groups. And then dependent is the same thing as there is an association, there is a relationship, and that is basically when the percentages are different for the variables. So for example, if I see a difference in first class on alive versus dead, second class on alive versus dead, if there's a difference between those percentages, then I say that there are dependent variables or there is an association, because clearly those two things are having an effect on each other. So just to show you one that doesn't have an association or some independent variables. So this is looking at level of education by gender for a survey or a sample of people. So we have males and females, and then we have whether they were not a high school graduate, which basically means they graduated high school but didn't graduate college, and then a college graduate. So we have numbers. Now, if I were just to look at the numbers, I might be tempted to say that males were more likely to not graduate high school because there was more of them. They were more likely to not or to graduate high school, and they were also more likely to graduate college. But reality, there's just more males in the survey. So we expect the male numbers to be a little bit higher overall because there's just more of them in the survey. So it's not a good idea to just look at the numbers to determine if these are related to each other. We need to be looking at percentages. So if I look at percentages, again, this one I separated based on the condition of gender. So I looked at just males, looked at what percent of males were not high school, and college. So 318 out of 1086, 603 out of 1086, 165 out of 1086. And then I did the same thing for the females. I also did the same thing for the totals. And what we can kind of see is that the percentages for male, female, and total of not high school, and college graduates are exactly the same. So even though the numbers are different, the percentages within each graduate category are the same for males and female in total. If I look at that on a graph, here's the graph that's just a regular side-by-side bar graph with numbers. Again, if I just look at that, I might be tempted to say there's a relationship between whether or not they graduate or their level of education and their gender. But when I look at a segmented bar graph with percentages, I notice those percentages are exactly the same. Those two bars look identical, which is telling us that gender doesn't seem to have any effect on level of education. There were just more males in the survey. So gender in this case would be independent of the level of education that someone has, according to this information from this survey of people. So again, that's one where they're independent variables or no association because the percentages are the same. So anytime you were asked a question about association between categorical variables, you have to look at percentages. You cannot just look at the numbers because the numbers are going to lie to you. The numbers are going to depend on just how many people are in each group. We have to be doing some kind of conditional distribution where we look at percentages. So that is it for this lesson. I will see you all next time.